Hello everybody, so I make that 3 o'clock, so we're going to start our webinar. I just want to welcome you all to our webinar, Oscilloscopes in Education, How PicoScope Meets the Challenges in Remote Teaching and Distance Learning. I'm Gemma Hull, the Marketing Manager here at Pico Technology, and I just want to go through some housekeeping. So your microphone is currently muted and your video is turned off. The webinar will run for approximately 45 minutes with 15 minutes of questions and answers at the end. Should you have any questions, obviously we'd love to hear any questions you do have. Can you please put them in the chat panel and I'll put them to our presenter at the end of the webinar. And just to let you know, the webinar is being recorded and a recording will be available approximately 24 hours after this event. So I will now hand over to our presenter today, Mike Purday, our Distribution Sales Manager. Thank you.
Ooh, thank you very much indeed, Gemma. And I'd like to echo Gemma's welcome to this webinar on PicoScopes in remote teaching and distance learning. So thank you very much indeed for joining us. We're going to spend the next 45 minutes or so looking at why PicoScope is ideal for remote teaching and distance learning. And I'd like to take you through, first of all, our agenda. So I'm going to be presenting the webinar, and we've got a couple of videos that have been prepared by colleagues of mine here in the test and measurement team, one by Bradbury, who's also part of the distribution sales management team, and one by Stuart Murlis, who's our applications engineer. Ooh, so first of all then, a look at a little bit of the background to Pico. So Pico Technology is a UK-based company. We're headquartered just outside Cambridge here in the UK. We were founded in 1991, so we're nearly 30 years old. We're going to be 30 years old in July. And we've been very proud of the fact for the last 29 years, we've shown continuous year-on-year growth, and we're on target to match that trend again for the 30th year. So extremely proud of that fact, and we're a privately owned company, and the continuous growth has been fantastic. So our board and our owners are very proud of that. As you may well know, we are a manufacturer of PC-based test and measurement equipment, and we pride ourselves on supplying T&M equipment at fair prices, and this equipment is ideal, as you'll see over the course of this webinar, for teaching and for laboratory work. We have regional operations in the United States and also in China, in the Asia Pacific region, and we're able to support our customers globally with a network of distributors that are able to support and supply our equipment in country. And you can see a list of our distributors, global distributors, on our website. In terms of size, we're about 130 employees and growing. We're adding to the staff count all the time. So that's a little bit of an overview about us. You can find out more details on our website, picotech.com. So taking a look then at the agenda for this webinar, we're first of all going to look at the background, so how teaching has had to adapt in the current environment, the current pandemic environment, and what alterations universities and colleges have had to make in order to be able to deliver our content remotely. We're going to then spend a little bit of time looking at why PicoScope is an ideal partner for our education, not only the hardware, but also the PicoScope software. And at that point, I'm going to run a demonstration of our 2204A, our entry-level PicoScope, together with PicoScope 6 software, and that's a demo that's been pre-recorded by my colleague Bradbury. We're then going to move on and look a little bit at how universities and colleges have used PicoScope to meet requirements for distance learning and remote teaching. And at that point, I'm very pleased to be able to share with you a pre-recorded interview with the University of Birmingham on their use of PicoScope. There's a use case scenario there. They've used and adopted PicoScopes for remote teaching. So I'll share that pre-recorded video with you. And then towards the end of the webinar, we'll look at other Pico products. So we have a portfolio of products that include RF products. And again, some of those are ideally suited for educational use. So we'll talk briefly about those. And we'll finish the webinar with a brief demonstration of our VNA, our Vector Network Analyzer, together with Pico's Network Metrology Training Kit, which is an ideal pairing for teaching our introduction to the use of VNA technologies. So first of all, then, a little bit of background. How has university teaching had to adapt to the current pandemic situation? So we all have been living in a slightly different, rather strange times for nearly a year. So we've all had to adapt the way we work and the way we deliver content, and universities are no different. So at the start of the pandemic, back in March of 2020, it was unclear how long remote learning and remote teaching would need to carry on for. I think we thought that perhaps the pandemic situation was going to be over quite quickly, and here we are nearly a year later, still in measures to deal with it. So some organisations moved quite quickly and early to declare that online teaching was going to be their modus operandi for the next academic year. So I'm quoting here the BBC News website from the 19th of May 2020, where it says that the universities of Cambridge and of Manchester moved very quickly and very early on to adopt to online teaching. Indeed, the University of Cambridge said that in the academic year commencing in September of 2020, that there wouldn't be any online, any in-person teaching. All teaching would be online. So many other institutions have also followed that lead, the early lead that Manchester and Cambridge took. But everybody's faced challenges in having to adapt to deliver content remotely. So quoting the UWE, University of West England in Bristol, lockdown uncovered numerous challenges and barriers with online learning, but also proved how effective it can be. So one of the things that I'm going to talk about, one of the themes to this webinar is the effectiveness of the use of Pico's products in overcoming those challenges and barriers and delivering effective online learning strategies. So what are the challenges of teaching engineering remotely? What are the issues? So looking briefly at some of them, then obviously teaching engineering is a practical subject. So teaching would normally take place, as well as academic lectures. Teaching would all normally take place also with the practical sessions in a lab with test equipment in that laboratory. And clearly, with students studying remotely from home or from wherever, that is not possible. So that's one challenge that has had to be overcome. Year groups can often be large, so depending on the size of the institution and the size of the intake, then you can be looking at cohorts that are perhaps more than 200 students. So you've got to have the ability to get equipment to large numbers of people. So remote teaching and distance learning has to be straightforward, both in terms of the course material, the syllabus, and in terms of the equipment that's used, because supporting that equipment remotely is more difficult potentially, and delivering the content that the syllabus remotely is equally a challenge. So focusing specifically then on the equipment that's involved, the equipment needs to be portable, it needs to be easy to use, and obviously because of the cohort size, the sheer number of people, the sheer amount of equipment that you might need, it needs to offer excellent value for money. So universities all over the world have turned to us here at Pico to overcome those challenges and to be able to use Pico products to deliver our teaching remotely. So a little bit of a look at why PicoScope is the ideal partner for education. And there's quite a wide range of reasons, and we'll explore these in a little bit of detail. So firstly and foremostly, the form factor of our PC connected oscilloscopes is a major plus. So the ultra compact design, you can see our 2204 there, both flat on a picture on the right hand side, but also being tucked into a shirt pocket on the left hand side. So very small, ultra portable, ultra compact design allows use anywhere. So very important, because obviously bench space is a premium if people are working from home, and you need to be able to send the equipment out to the students to be able to use. So the ultra compact design and form factor are very important. Value for money. Now, we've touched a little bit on the size of the cohorts. Value for money, very important. So the entry level 2204A that you see there in the pictures is $139 US or 119 euros or 99 pounds sterling. So that sort of price level makes large orders for teaching entire groups, entire cohorts very possible, because you're looking at something that in many respects, many cases, is not much more than the cost of a textbook. So it's very possible to purchase a PicoScope for each student. I mentioned before the PC connected aspect of this. So obviously, everybody, all students have got access to a personal computer. And one of the great beauties of our PC connected oscilloscopes is about 70% of the functionality you would see from a traditional oscilloscope is contained in that PC. So then you're saving on both cost and also on bench space. So using the PC connected part of the oscilloscope in a PicoScope means that the students have already got the access to that PC, and they've already got the familiarity with the use of the PC. So all of the above is a combination really which offers advantages that traditional benchtop oscilloscopes can't match. You wouldn't be able to ship them out to students. They're not intuitive to use in the same way as PicoScopes. So all things that have stood us in very good stead for this remote teaching and distance learning. So just touch then very briefly on the software. So PicoScope 6 software and remote teaching. The software itself is free of charge, so it can be downloaded as many times as you wish onto as many multiple machines as you wish. And importantly, once you purchase the hardware, the software is upgraded. If the software is upgraded, the software is upgradable, and those upgrades are retrospective. So retrospective upgrades for existing hardware users. It's a proven and reliable software platform which works with all PicoScopes. So worth pointing out that the software package is the same for the PicoScope 2204A, the entry-level scope, throughout the entire real-time oscilloscope range. So topping out with our 6000 range, 500 megahertz high bandwidth, high specification scopes. So once the students become accustomed to using PicoScope 6, it's the same software platform that they're going to be using if they move to use PicoScopes in later roles, perhaps post graduate education, or indeed moving out into industry. So that's another important point. If you have students that are studying remotely and perhaps their first language is not English, they might prefer to use the software with their own local language, and we have multiple language support built into the software. And as I mentioned, the software can be downloaded onto any PC anywhere you wish, and there's the possibility of allowing students to simulate hardware if needed, so they can get up and running very, very quickly, and they can do so if they wish, before they receive the hardware. And a final thing with the software to bear in mind is that the online file transfer allows easy transfer of files from the students' PCs to back to academic departments. And this means that marking coursework, if there's any assessed coursework or any questions about what the students have done, it's very easy to deal with that. So another major plus point. So we've got the hardware, we've got the software. Now, the final thing, obviously the final part of any practical work, is the ability to actually build devices and circuits to test. So relatively recently, Pico has started working with analog devices using their parts and component kit, the ADALP 2000 parts kit, which contains a large selection of components which are ideal for creating circuits and devices. So we would recommend this kit. It's inexpensive. It's around £50 sterling, and it's a versatile way for students to build and test circuits. So what you see in the pictures below is you see the parts kit on the left hand side with all the different components in, and then on the right hand side you see a PicoScope. And there's a PicoScope 2000 there being used to probe a device that one of my colleagues, Stuart Murlis, has built. And he's built an audio amplifier, and he's using the PicoScope there to probe the circuit under test. So that's the third part of the system. So you have the hardware, you have the software, and now we're recommending these analog devices kits as a way of building circuits for students to actually test. So at this point, I'm going to move to a video that one of my colleagues, Mr. Carl Bradbury, has put together. So Carl's done a brief demonstration video looking at the hardware and the software with the 2204A, looking at testing a bandpass filter. So I'm going to play you a short video demonstrating that now.
In this demonstration, we're using the PicoScope 2204A to characterize the frequency response of a bandpass filter circuit. The 2204A is a compact 10 MHz 2-channel PC oscilloscope. Priced at £99, it's a popular choice of oscilloscope for teaching labs. It includes a 100 kHz signal generator with sweep function and connects to a PC running PicoScope software, which includes a spectrum analyzer mode. The circuit under test is a simple bandpass filter using an RLC network to cascade a low pass and a high pass filter. The center frequency is calculated to be around 7.3 kHz. With a signal generator and channel A of the oscilloscope connected to the input of the filter and channel B connected to the output, I select the signal generator icon and turn on the signal, which is currently set to sine wave of 1 kHz. We can increase the frequency manually and see how the circuit behaves at set frequencies. Seeing the phase relationship between both channels and the amplitude of channel 2 as we step through the frequencies, like so. Or we can do a continuous sweep from 1 kHz to 20 kHz and observe the changes in real time. But to get a frequency plot, we need to go to spectrum mode and select 24 kHz span, and we only want to see, we're only really interested in channel B, so I'm going to turn off channel A, and then I'm going to select in the spectrum menu a linear scale, because the circuit doesn't really have a great deal of dynamic range, so we don't need to be in logarithmic. Just adjust the scale so we can see the baseline. And then really we want to see what is happening at the peak, so I'm going to reduce the spectrum bins and put it into peak hold, gradually it will build up a plot of magnitude versus frequency. Like so. And we can turn on a measurement on the B channel, which is frequency at peak. And I think we just need to let it run through again before it can find the peak for the measurement. Here we can see the measurement reaching its peak at 7.7 kilohertz.
Okay, so thank you very much to Carl for that. So that gives you, I hope, a flavour of the PicoScope 6 software and how a PicoScope 2204A can be used in a real application. So I mentioned earlier in the presentation that quite a number of universities, organisations have adopted PicoScope for remote teaching. So I wanted just to highlight some of the organisations that have partnered with us and that are working with us. All of the logos that I've got here that I've taken from the relevant press sites for use in the public domain. But you can see we've got a number of universities here. A lot of them are UK based. Obviously, we're a UK company and we've worked quite closely with a number of UK organisations to produce this webinar. But we have got customers in universities and academic institutions globally. So the University of Boston has bought quite a number of 100 PicoScopes for use in their teaching kit. They put a kit together for remote teaching, and the PicoScope is one part of that. Vermont Tech College in the USA, and also as far afield as Seoul National University in Korea. So we're delighted to be working with all of these institutions, and it's great that all of these different universities have taken up PicoScopes for their remote teaching challenges. So some of the universities we've been working with have been kind enough to give us some feedback on how the PicoScopes have been used in remote teaching. So I've quoted some short excerpts here. So the University of Bristol here in the UK, PicoScopes are enriching and fun compared with the lab, which I think is a great quote because it really highlights that teaching and remote learning ought to be enjoyable. So the students are enjoying working with the PicoScopes. They find them fun and enriching, which is great. Vermont Technical College in the United States came back to us and said, we're absolutely delighted the students and the faculty both love the scopes, which is great. So both sides of the educational system, the faculty and the students are really, really impressed. And then thirdly, the University of Birmingham said rather dramatically, but rather lovely quote, PicoScope saved our lab. And what they realized very early on was that remote teaching wasn't going to be needed in order to keep things going. So in-person teaching wasn't going to be possible. And the PicoScopes allowed them to continue delivering the content that they wanted to deliver. So that's fantastic. Really nice feedback there. So 2 universities very kindly agreed to go a little bit further and give us a testimonial on the use of the products. So Dr. Francesca Fornetti, Senior Lecturer in the Department of Electrical and Electronic Engineering at the University of Bristol, kindly agreed to give us a testimonial. And he has incorporated again the PicoScopes within home laboratory kits. So he's come back and he said that the students really enjoy using the lab kits and enjoy using the PicoScopes. And he talks about there being a much more relaxed environment, free of time pressures that timetabled labs can bring about. So obviously there's an advantage there that the students can work at their own pace. And he also looks at the theme that students can gain a greater insight into the operation and characteristic of circuits. So going back to talking about the parts kit, students can actually build their own circuits, they can experiment with their own ideas, try out different circuit configurations, and Francesco feels that this greatly enriches their learning experience. So fantastic to have such a positive testimonial on that use. It's really good. And secondly, Roger Berry, teaching fellow in the Department of Mechatronics Robotics at the University of Leeds, kindly agreed to give us a testimonial. And Roger says, after test driving, nice phrase, test driving the 2204A from a practical lab perspective, it was an obvious choice. So the scope, despite the fact that it's very, very good value for money, performed excellently. And he goes on to talk about the advantages of remote labs, stating in his opinion, they actually provide a better experience for students, which is very interesting. So students, he says, are more self-motivated. They become more, with the correct support, more independent. Now, another interesting point, because obviously undergraduate teaching is usually exactly that. It's teaching led, as opposed to master's level or doctorate level education, where the students are working themselves to learn. So it perhaps gives an edge to students studying at the undergraduate level to become more independent and go and find the answers out for themselves. And he says it also allows them, the remote teaching also allows them to gain more knowledge and to experience consistent teaching. So lovely testimonial there, and very pleased that the PicoScopes have worked out so well for the University of Leeds. That's great. So I mentioned earlier on that we were delighted to have an interview with a leading UK university about their experience of adopting PicoScopes for remote teaching. Now, Dr. Ken Elliott at the University of Birmingham kindly agreed to do such an interview with me. We recorded this last week, so I'm going to play this back in a second, but the University of Birmingham purchased 250 PicoScope 2204As for remote teaching, and these have replaced lab-based teaching for students studying remotely from home. And like a lot of other partners, Dr. Elliott's produced course material for the students to use with the units for remote learning. So obviously we talked about that being an important part of the teaching experience. And here at Pico, we're very interested in if universities want to collaborate with us to create a repository for such course material, then please do get in touch, because it would be of benefit to the academic community more broadly if we were able to have a repository for such course material. So that would be, we'd be very pleased to hear from anybody that would be interested in that. So I've got this short interview with Ken, which I'm going to play for you now. And I'm joined by Dr. Ken Elliott from the University of Birmingham, who's very kindly agreed to talk to us briefly about a real test case of using PicoScopes in education. So, Ken, good afternoon. How are you?
I'm good, thank you.
Good, excellent, very well indeed, thank you. So, thanks ever so much for agreeing to talk to us about the use of PicoScopes in remote learning and education for our webinar. Could you possibly give us a little bit of background about your use case? So, what challenges you were facing and why you contacted Pico in order to talk about using PicoScopes for your students, please?
Well, basically, we realised quite early on that the labs may not run, so I decided I would try and invent some home experiments. And the first thing that occurred to me was doing some electronics and using the PicoScope. I already had a PicoScope, which I bought a couple of years earlier, and found it fantastically easy to use. With good display and things like that, and thought it was the obvious thing to use. So basically, I contacted PicoScope and said, we've got 200 students and we may want to run 200 experiments with 200 students. Can you supply 200 PicoScopes? And they said, yes, we'll be able to do that. And we ordered the PicoScopes, and I designed some experiments, and we probably got 250 students all over the world doing my experiments. I've set some experiments on DC measurements and then on AC, and it's all going quite well.
Fantastic. So that was obviously driven by the current climate and the pandemic and the need to be able to teach remotely as opposed to teaching in the lab.
Absolutely, yes.
Okay, so it's interesting you mention students from abroad. So I guess the form factor and the portability of the PicoScopes was important. The ability to actually get them to their destinations.
Well, clearly, I mean, we couldn't send bench type scopes anywhere around the world, and these are quite tiny and easy to use, and obviously work on multiple platforms as well, which is also very useful. So then we just posted out to all sorts of places: Norway, China, all over the place. Mostly in the UK, and a lot of students are working from home, and some of them are on the campus and have actually come onto campus to use them. But it's mostly at home.
Okay, that's very interesting. So why did you choose Pico? Obviously, we've talked about the form factor, but were there other factors that influenced your decision to go with this?
Well, basically, my experience of using them and finding them so easy to use and so intuitive. And of course, I mean, students are not very happy with using bench type scopes with knobs and controls and things, whereas they're quite familiar with using a mouse and cursors and things like that. So it's a much more easy way for the students to work, and that's one of the main reasons we went for them.
Okay, that's good to know. I guess everybody's got a laptop computer, haven't they? And one of the great advantages of using PicoScopes as opposed to benchtop scopes, even in a more traditional environment, is the fact that you've already got that processing power on your desk. Absolutely.
I mean, so basically the student just plug them in. We send them the components to do the experiments, and there's a script which is online, and off they go. And to be honest, we have Zoom sessions where they can get support, but we haven't had very many people asking for help because everything's worked out so well.
Wow, that's brilliant. Really good to know. So you say you had 200 students. So did you buy 200 PicoScopes? It was one per person.
In fact, we bought 250 in the end because the university upped the number of students on the course. So we bought 250 PicoScopes, and each student got one. Normally in the lab, students work in pairs, but in this case, obviously, that couldn't happen because of the lockdown. So we bought one for each student.
Okay, that's good. And has the feedback, you mentioned that the feedback's been positive. Is there anything in particular that the students have picked up on that they like about the PicoScopes as opposed to more traditional alternatives?
Well, I think it's just intuitive, really, that they can see what they want on the display. The ability to have a large display, on the size of a PC monitor, and also the fact that for our point of view, it allows you to make measurements, and it gives you a value for a voltage or whatever, and a resistance too. And the fact that the devices are 8-bit is quite useful. You might think, oh, that's quite low resolution. But the fact it's 8 bits means the students are then aware of the errors and can take that into account.
Another interesting point. So, of course, we do make and sell higher resolution PicoScopes up to 16 bits vertical resolution. And I guess that this introduction to the PicoScope ecosphere, if you like, is really good for students moving forward. So if they become accustomed to using our software and our products, I guess that sets them up for the future as well, doesn't it?
Well, I think the thing that impressed me more than anything really was that the PicoScope 6 software, which you provide, obviously works on very high-spec machines, but you have all of the facilities which you expect to see on a high-spec machine on a very cheap piece of kit with low resolution. So doing mathematical functions, subtraction, that kind of thing, and doing the spectral analysis, all of these you'd never expect to find on a piece of kit that's costing like £100. So that's made a massive difference, really.
Okay. Yeah, we've done that deliberately because we want the entry-level scopes to have the same level of feature and experience as the products higher up in the range. So it really is, once students are bought into that, then they can transfer. And the PicoScope 6 software works with all our scopes up to 500 megahertz high bandwidth scopes, so that once they become accustomed to that environment, then they're good to go for the future into their careers. So that's the reason we've done that.
Well, absolutely. I mean, the point is that the students see these features and think, this is just amazing. This is exactly what we want to do. And, okay, as you say, they're using a relatively entry piece of kit. But, in their future careers, I guess they'll say, oh, we want a PicoScope. In fact, a number of my colleagues who work in industry, I've talked to them about the PicoScope, and they've said, oh, yes, I'm going to get my employees to get one of these. a chap who's an engineer who travels around and fixes bits of high-tech equipment has actually bought one, and this is a result of that. So
that's brilliant. That's really good. So word of mouth referral is really good.
Yes.
Yeah, that's good to know. So moving forward, obviously, we're all looking forward to when we come out of the current pandemic situation and we get it back into more something more approaching normal. Do you anticipate using the PicoScopes moving forward for future year groups and to do these experiments to give you the flexibility that you've gained from them?
Yes, well, as I said, we normally work in with students in pairs. So we've got 250 PicoScopes. I think we'll continue to work in pairs, and so basically we're going to have like 100 PicoScopes spare. So I imagine what we will, this hasn't been decided yet, we will probably get those moved into the second year. So anytime a student in the second year wants to do an experiment that needs an oscilloscope, they'll use the PicoScope, which they've already seen. So it will be a continuation. And what will happen in the third year, I don't know, but certainly we expect to use it in future years.
Okay. That's really good to know. And you mentioned developing the lab experiments. Is there anything else, material-wise or otherwise, that the Pico perhaps could help provide? So we've talked a little bit about the possibility of a resource for curriculum moving forward that academic institutions can share. Is that something that you think might be a useful repository?
Well, I think it might be. Yes, I think most people like to generate their own experiments, and I certainly do. But I don't see any reason why we shouldn't be able to share some of this material. Yeah.
Okay, that's interesting. So again, looking forward, I think that we're probably all going to be working a little bit differently in the future, and I guess that the portability and form factor, if you do need still to do some remote working even after normality is returned, gives an advantage if there are some students perhaps who are working remotely, or some international students who are doing distance learning as well.
Well, absolutely. I mean, there is a possibility that we may actually just say to the students, look, this is your PicoScope. Use it in all 3 years. Anytime you need to use an oscilloscope in the laboratory, just bring your PicoScope along, like you would bring your laptop. So that's another possible way. It hasn't been decided yet, but that's possible.
Okay. Yeah, I guess they're relatively speaking inexpensive enough that they could be viewed as a resource for that student, a bit like textbooks, etc.
Yes, I mean £100, compared with the fees the students are paying, is not a lot of money. So
yeah, absolutely. Yeah. So as you say, for £100, you get a fully featured oscilloscope that they could potentially keep and use.
Absolutely, and then when they leave, they graduate, they may take it with them. So it's. I think that we haven't decided. But it's not a lot of money, in the budget of the university, and I think that might even happen.
Okay, that's wonderful. Well, Dr. Elliott, thank you so much for your time, and I'm really pleased to hear that you've had such positive experience with the PicoScopes. That's really great to know, and we really hope that we see a future generation of engineers coming out of the University of Birmingham with PicoScopes in mind for their future test and measurement requirements.
I'm sure that would be true.
Okay, wonderful. Thank you very much indeed.
Pleasure.
So thank you again very much to Dr. Elliott for taking the time to produce that recording with me. I hope that showed everybody on this call the real use case for PicoScopes in education. So it's been a real success story for the University of Birmingham and for their students, and it enabled them to carry on teaching remotely during the current pandemic situation. So we're delighted with that and with the feedback that we've got from that. So I promised at the beginning of the webinar to talk a little bit about other Pico technology test and measurement equipment for use in educational applications. So we're best known for our real-time oscilloscopes, which, as I mentioned, we have in up to 500 megahertz bandwidth. But we also offer other products within our T&M range suitable for teaching and for remote learning. So that includes, these products include a range of data loggers. You see in the picture there, the middle picture there, with the PC, with the laptop connected to one of our data loggers. That's a TC08 thermocouple temperature data logger. and we have a range of data loggers for measuring parameters such as voltage, current, temperature, etc. But in addition to that, we also have some high-end products, which, like all of Pico's products, are extremely cost-effective, exceptional value for money at their given price point. And they include vector network analyzers at both 6 and 8.5 gigahertz. So you can see a vector network analyzer picture at the left-hand side of the slide. And we also offer a range of sampling oscilloscopes as well. So we do have RF products in our range that are suitable for use within educational applications. It's also worth mentioning as a final point, all of our products have documented programming interface API for teaching programming. So you can not only use the products to teach and to learn, but you can also teach the programming of them as well. So as a final demonstration, then, I'm going to show a short video produced by one of my colleagues, Stuart Murlis, who's our applications engineer here at Pico T&M, and he's looking at the vector network analyzer together with our network metrology training kit. And again, this is designed to couple with the VNA for teaching applications. So a third short final video here.
My name is Stuart Murlis, and I'm an FAE here at Pico Technology. In this short video and demonstration, I'm going to be talking about the Network Metrology Training Kit and the Pico VNA 106 to characterize a low-pass and band-pass Butterworth filter. The Network Metrology Training Kit is designed to support learning practice and experience of RF and network measurements in the sub-6 GHz frequency range. The trainer or the student needs only a vector network analyzer and the Network Metrology Training Kit to start performing network measurement tasks. Unsurprisingly, Pico recommend the use of high-performance VNA instruments, which are exceedingly good value. In this first example, we are going to be measuring the on-PCB low-pass Butterworth filter example. Having calibrated the SMA test ports, I've now connected the PCB low-pass filter. In the screen, we can see our results. The measurements reveal the filter to have a 3 dB point of around 260 megahertz and the group delay that peaks sharply at the same 3 dB roll-off point. Our time domain shows a relatively tidy pulse response. This is a reflective filter, one that reflects stop band signals rather than absorbing the energy as an absorbing filter would. It also becomes clear that for small receive signals with a deep attenuation stop band, the VNA struggles to resolve phase and thus group delay. Group delay being the rate of change of phase. In this illustration, we are going to be taking some measurements from the on-PCB bandpass Butterworth filter, wideband sweep after calibration. Our first results will initially show that the bandpass filter is fully reflective in the stop bands with 2 relatively good match bands. In our S21 log mag results, what we can see is the pass band is between 150 to 250 megahertz. And in the deep stop bands only goes out to about 2 gigahertz. You will also observe the reinsertion pass band at around 3 gigahertz. What we can see in our group delay measurements is that we have very significant group delay in the pass band and phase and ungroup delay uncertain in the stop bands. In our final illustration, we are going to take a closer look at the Butterworth band pass filter on the PCB. The measurement, as you can see, uses 10 megahertz to 610 megahertz with 201 sweep points. Our initial observations show on the S11 log mag that the band pass filter is fully reflective in the stop bands, while the pass band, S21 log mag, is around 150 to 250 megahertz. Our group delay here results show that there is a very significant group delay and spread of delay in the passband.
Ooh, so thank you very much indeed to Stuart for that. So I hope that gives everybody on this call a little bit of a taste of the Pico RF product portfolio and the use of the vector network analyzer in teaching applications. So with that, I'll then just move on to summarize. So obviously, I hope that I've demonstrated throughout this webinar that PicoScope and indeed the Pico product portfolio is great for remote teaching and engineering. There's been very substantial uptake of our products for this application, and we've demonstrated the numerous advantages of the Pico solution over our competitors in terms of form factor, software, support, all of the things that make Pico possible and feasible for remote teaching and distance learning. And those advantages have resulted in wide adoption of the technology by universities and colleges internationally. And I showed you the slide with some of the organizations that we're working on. So we then just touched on briefly the other T&M products, test and measurement products that we have, which are also ideal for use in academia, the vector network analyzers, the data loggers, etc. Probably worth pointing out that if you, or if there are any of our distributors on this call who have customers who are interested in ordering for the next semester or the next term or indeed the next academic year, it's very much worthwhile ordering in advance. So we've been selling very large quantities of these units for teaching, and as a consequence, some of the lead times that we're seeing are a little bit longer than perhaps we would normally see. So if you're planning on buying units, potentially hundreds of units for a teaching application, then it's definitely worth considering working with us to make sure that we can help you with as much notice as possible. So that's consideration for anybody looking to do this, perhaps for the academic year that starts next September. So as a final note, if people want to see more details on our educational program and our educational website pages, Gemma has just posted a link in the chat forum with the landing page for the educational website pages, so please feel free to browse those. So just in concluding, I'd like to say thanks very much indeed again to the academics who helped us produce this webinar, particularly Dr. Ken Elliott from the University of Birmingham, Dr. Roger Berry from the University of Leeds, and Dr. Francesco Fornetti from the University of Bristol. Thank you ever so much for all the content and all the help. And also to my colleagues here, Gemma Hull, our marketing manager for hosting, and to Carl Bradbury and to Stuart Murlis for producing the videos. So I hope you found that webinar useful. I've seen there've been some chat questions come through, some of which have been answered as we've gone along. And I'll hand back to Gemma Hull as our host for any further questions that need to be answered.
Okay, thank you, Mike. There was a comment and a question that was put into the chat box, as you said. So Arthur mentioned that if local government do not allow to finance a scope as equipment for every student because it's not a study book, a solution could be to put it on the study book list so it gets paid by local government, as that is what they did in Holland. So it's just a comment for everyone else. And Len had a question which was, are there any cables included with the scope? I'm thinking particularly of the ribbon cables shown in the photo, and a couple of our colleagues have answered that, but just to recap that the 2204A that was shown in the picture, I believe at the time, does not come with the ribbon cable or the digital cable as we call it. But if you buy any MSO option, and I put a link down in the chat box, then they come supplied in a kit which has that cable with them. I don't know if you want to add anything else to that, Mike.
No, I think it just obviously the probes, the 2204A would come with probes. There is a probeless option as well. So make sure that you order the scope and make sure that it comes in a kit with the probes if you want the analog probes as well. We do offer versions with digital channels as well if there's a need to have digital channels, and again make sure that you order the MSO versions if that's what you need. So just be careful about what's being ordered.
Lovely. And that's it from the questions. I think everyone else is just saying thank you to you for a good webinar.
Ooh, well, no, thank you very much indeed to everybody for attending, and thank you for all the kind words in the chat. That's super. It's been
Thank
a
you.
real pleasure to be able to deliver the content, and I hope that we can continue bringing PicoScopes to customers for their educational remote learning and distance learning applications.
Lovely. Right. Thank you.
Okay, wonderful. Thank you, Gemma.